Ever wonder how your phone gets better at understanding you, like recognizing your voice or suggesting the perfect playlist, without sending all your personal data to a server? It's all thanks to a revolutionary AI technique called federated learning. Think of it like a group project where everyone works on their own part and shares only their final answers, not their entire notebook. This way your data stays private, but the AI gets smarter for everyone. But here's the catch. As AI models grow bigger and more complex, this process can get slow and clunky. Imagine hundreds of devices trying to send their updates at the same time, like a crowded room where everyone's shouting. The signals get mixed up, and the AI struggles to learn. That's where a groundbreaking solution comes in, over-the-air federated distillation. So what's the trick? Instead of sharing entire models, devices send summaries of their work, like key takeaways from a lesson, not the full textbook. These summaries, called soft predictions, are like educated guesses about what the AI has learned. For example, if your phone is learning to recognize cats, it might say, "I'm 80% sure this image is a cat." These guesses are then combined in the air, like a symphony where each instrument's sound blends smoothly. The server hears the combined signal and uses it to update the model. But here's the twist. Wireless signals aren't perfect. They get distorted by interference, fading, and noise, like a phone call in a crowded room. To fix this, researchers focused on transceiver design, the hardware and algorithms that send and receive signals. They optimized these devices to direct signals like a spotlight, reducing interference and making the process faster. The math behind this. It's no walk in the park. The problem is non-convex, meaning it's like trying to find the top of a mountain with a foggy, shifting landscape. But here's the genius. They used a technique called semidefinite relaxation to simplify the problem, turning it into something solvable. The result? A system that uses up to 70% less data than traditional methods, with only a tiny drop in accuracy. Why does this matter? It means AI can learn faster and more efficiently, even on devices with limited power or connectivity. Imagine healthcare apps that analyze patient data without sharing sensitive info, or smart cities where sensors collaborate without overwhelming networks. So next time your phone gets smarter, remember, behind the scenes, innovations like over-the-air federated distillation are making it all possible. Thanks for watching. Hit subscribe for more deep dives into the science shaping our future. Let's dive deeper. Traditional AI training is like a group project where everyone sends their work to a central server. But in reality, data is scattered on your phone, a doctor's computer, or a factory's sensors. Sharing all that data risks privacy, slows things down, and can even be illegal. Federated learning solves this by letting devices train a model locally and only share updates, not the raw data itself. Think of it like a classroom where students study their own notes and then share key insights, not their entire homework. But here's the twist. Training across devices isn't easy. First, there's the bandwidth problem. Sending model updates between devices is like trying to stream a movie over a slow internet connection. It's slow and inefficient. Then there's non-IID data, short for non-independent and identically distributed. In plain terms, each device's data is unique. Your phone's photos aren't like your friend's, and a hospital's patient records don't match another's. This makes it hard for models to learn broadly. So how do researchers tackle these issues? Enter federated distillation, a clever trick where devices don't just share model updates but knowledge. Imagine a classroom where students teach each other. Instead of retraining a model from scratch, devices share soft labels or hints about what they've learned. This reduces the data sent and helps the model adapt to diverse datasets. Recent breakthroughs are making this even better. For example, communication-efficient federated distillation, CFD, uses smart compression to shrink updates, like sending a summary instead of a full report. Other methods optimize how devices collaborate, ensuring the model stays accurate even with limited communication. It's like fine-tuning a car's engine to maximize speed without overheating. Why does this matter? It's the backbone of privacy-preserving AI. From smarter voice assistants to safer medical diagnostics, federated learning keeps your data secure while making AI smarter for everyone. Next time you use an app that adapts to your habits, remember, it's powered by math that lets machines learn together without ever seeing each other's secrets. Thanks for watching. If you want more deep dives into the science behind your tech, hit subscribe. Stay curious, and I'll see you next time.